All right, so this is 12.3. When we're talking about the concentration solutions, I've divided this into two parts. In the first part, we're going to talk about molarity, and in the second part, molality, which are very similar words. And both of them they're just two different ways of describing the concentration of a solution. So today, this lesson is on molarity. I'm going to try to record these a little differently. Instead of going through Zoom, I'm just recording on my phone and then trying to upload. We'll see how that works. So I'm just going to fill in the notes kind of along with you. I will post the PowerPoint, but it's not probably super helpful. So if you're looking down your notes, what you can see is that we have a few definitions and things that we're going to give up at the top, and then we're going to work some practice problems. They're just not numbered. And so those continue on the second page. Okay. So we're going to start with a definition of concentration. And concentration is a measure of the amount of solute in a given amount of solvent or solution. All right, so the downside to doing it this way is that I'm actually on video, and so it's zoomed in a little bit more, so I can't use the whole space. All right, so when we're talking about concentration is we can be very vague and describe something as being dilute or concentrated. So like if you look on like containers of juice, sometimes it'll say from concentrate, right? Or it'll say a concentrated solution. That just means you have a lot more solute than the solvent, right? So it's kind of more saturated. So we can use the terms dilute and concentrated, which are very vague. Dilute would mean you have less solute, and concentrated would mean you have more, but they're not very specific terms. So instead, what we're going to describe is molarity. The definition for molarity is the number of moles of solute in 1 liter of solution. Okay, number of moles of solute in 1 liter of solution. So this somewhat relies on like molar mass conversions, right? So for instance, sodium hydroxide NaOH, the molar mass is 40 grams. Okay. So if you dissolved 1 mole of NaOH, sodium hydroxide, in enough water to make exactly 1 liter of solution, then you've made a 1 molar solution. Okay, so let me write that out over here in this space. I'm going to change color. All right. Okay, so if we have NaOH, right, it has a molar mass of 40 grams per mole, right? So if I dissolve 40 grams of NaOH in enough water to make that's 2 words, to make 1 liter of my solution. So we have to phrase it this way. We're not dissolving it necessarily in 1 liter of water. It would probably be a little bit less because 40 grams of sodium hydroxide is going to take up some space too. Okay. So we make 1 liter of our solution, well, because we have 1 mole here, right? 40 grams is 1 mole of our substance. we've made a 1 molar solution. Okay, so the molarity formula and the units is the next thing. So molarity, which we symbolize with a capital M, is equal to your amount of solute, right? And that's in the number of moles per volume of solution. Okay, and that one's going to be in liters. All right, the molarity, capital M, is the amount of solute you have in moles divided by the volume of the solution. So we're going to do this a few times and hope one of the best ways to make molarity make sense is just to do some practice problems. All right, so you have these in front of you, so if you can't read the whole line on the screen, you can read it on your paper. So we're just going to do a whole bunch of practice problems. After a couple of them, you should probably start pausing the video and seeing if you can do them on your own. I'll kind of let you know when you ought to pause. So we're going to go down to the first one, which is that you have 3.5 liters of solution, and it contains 90 grams of sodium chloride, and we want to know the molarity. So our first step, we have the mass of our sodium chloride, but that's not what we need. We need moles. So my first step is to use the molar mass of sodium chloride. You're going to want your periodic table. And I'm going to convert my 90 grams of sodium chloride to moles. So 90 grams of NaCl, 1 mole is, let me get my periodic table and my calculator out. Sodium is 23. And chlorine is 35, so 58 grams of sodium chloride in 1 mole. So I need to figure out the, right, so that's how I'm going to figure out my moles. So 90 divided by 58 is 1.6 moles. Okay. I think it wants us to probably use 1.55, but that's okay. We're going to go with 1.6. It's fine. So now I have my number of moles. My second step is to take this number of moles and divide by the volume. So 1.6 moles in 3.5 liters. 1.6 over 3.5 is 0.46 molar is how I would say that. Okay, so 0.46 molar NaCl. Okay, and that is my final answer. Okay, so we'll do the next one together as well. Finding the molarity again. Okay, so it's the same set of steps. We have 2 liters of solution made from 14.6 grams of NaCl. So we're going to find the molarity of this set. So we're using the same, we're still using NaCl, so I don't have to do too much. Let me move this up. So I have my 14.6 grams. Again, I can't use grams directly. I have to convert it to moles. But I've already done the math. So that's 58 grams in 1 mole. So then 14.6 over 58 is equal to about 0.25 moles. Okay. So then I can take my 0.25 moles, divide that by the 2 liters. Okay. So we get 0.125 molar NaCl. Okay, should probably have the 0 in front of that. in front of that decimal. All right, so I would like for you to pause the video and try to find the molarity of the hydrochloric acid if you have 10 grams of hydrochloric acid in 250 milliliters of solution. Okay. So 10 grams of HCl has a mass of 36 grams in 1 mole. So 10 divided by 36 is 0.28. So then I do 0.28 moles. This is molarity, so I need this in liters. Okay, so remember milli to liters, I can move my decimal 3 to the left. Okay, and that is going to give me 0.25 liters. So 0.28 over 0.25 gives me 1.12 molar HCl. Okay, final answer there. All right, the next set, we are kind of going the other, we're going to solve for something a little different. So here it gives us the volume with 0.8 liters, and we know the molarity. We're going to figure out how many moles. Okay. It could even ask you how many grams. And I'm zoomed in. I got to keep paying attention to that. All right. So remember, my formula is moles over liters equals molarity, right? So I'm going to solve for my moles in this one, which means to solve for moles, I'm going to do my molarity times the volume in liters. So in this case, my molarity is going to equal, or my moles, my number of moles is going to equal to the 0.5 molar solution times the 0.8 liters of solution. So 0.5 times 0.8 gives me 0.4. Zero 0.4 moles of HCl. Okay. Let's see how I wrote that out. Turn that a little bit. All right. Let's do one more like that, and then I will let you practice on your own. Practice one on your own. So again, finding how many moles, this time of NaCl, in 1 1/4 liters of 0.330 molar. Okay, so my number of moles is going to equal to my molarity times the volume in liters. So I'm going to do 0.330 times 1.25, which is the same as 1.25 times 0.330. And I get really similar. I get 0.413 moles of NaCl. Okay, so there is my final answer. So try the last one on your own, and then turn the video back on and make sure you did it correctly. So we're doing the same thing. So my number of moles is going to equal my molarity, 0.5 molar, times my volume, but I have to convert this to liters, which is 0.5 liters. 0.5 times 0.5 should give me 0.25 moles of HCl. Final answer. Okay, so these are not too terrible. All right. Last set of stuff I wrote on the table. It's terrible. Okay, so here we're going to be doing some more calculations. We're going to try to produce 40 grams of silver chromate. So I'm going to need at least 23.4 grams of the potassium chromate, which is this right here. But all I have on hand is 5 liters of a 6 molar solution. Okay, so I'm going to figure out what volume of the solution I need in order to get, that 23.4 grams. Okay, so this one requires a little bit more thought in how we're going to approach this. Okay. So I need to figure out what volume of that solution would contain 23.4 grams. So I need to first figure out how many moles is 23.4 grams. Okay, so my first step, I'm going to convert grams to moles. Okay, figure out how many moles of this do I need, right? Because molarity is how many moles per liter. Okay, and then I can figure out the volume, right? So my second step is to find the volume. Okay, the volume that would contain that number of moles. All right, so in this one we're solving, right, so if we think about it, moles per liter is equal to molarity. This time we're going to end up solving for the liters. Okay, so I'm going to start by figuring up the number of moles that are in 23.4 grams. Okay, so this is K2CrO4. So if you use your periodic table, you would find that the molar mass of potassium chromate, so we have 2 times potassium, which is 39, plus we have a chromate, which is chromium, which is 52, and then we have 4 oxygens, 4 times 16, so I get 194 grams in 1 mole. All right, so how many moles would this be? Right, how many moles do I need for that 23.4? I keep hitting the wrong button. 23.4 divided by 194 is 0.121 is what I get. They get 120. Okay, so they have a rounding difference. We'll go with 121. Okay. 0.121 moles is how much I need. So I am going to do moles per liter is equal to molarity, right? So I need to figure out how many liters of a 6 molar solution I need. That would be 0.121 moles. So to rearrange this equation and solve for liters, I'm going to divide by the molarity. Okay, so what I'm going to do to solve for liters is going to be equal to moles over molarity. Okay, because you'd multiply liters to the other side and then divide by the molarity. So you're going to switch those two. So 0.121 moles over the 6 molar solution and I need 0.02 liters of the K2CrO4 solution. Okay. So these take a little more thought. And then you have 3 more that are each asking you to find these same. You have 1 more that's asking you. So you have 1 more asking you for molarity, 1 more asking for moles, and then the last one is asking you for the volume. Okay, so I'm going to go ahead and ask you to just pause, try these three, and then come back and check all three at one time. If you really want to, you can do them one at a time. I don't really care. Okay, so finding the molarity is pretty easy, right? So molarity is moles over liters. So it gives me, this time again, it gives me the mass though. So 6.25 grams of HCl. There's 36 grams in 1 mole. Okay, we did that earlier. So 6.25 over 36.17. Oh, wow, I really wrote that wrong. 0.17 moles. All right, so we come back over here. 0.17 moles over 0.3 liters. And I get 0.57 molar. Okay. In the next one, how many moles are present? How many moles of Ki are present if you have 0.25 liters? Okay, so how many moles, right? My number of moles is going to be equal to my molarity times the liters. So 2.3 molar times 0.25 liters. Zero 0.575 moles of Ki. All right, and then finally the volume. Okay, so my molarity, so remember to find volume. I'm going to do moles divided by molarity. Again, this one gives me the mass and not the moles. So 32.5 grams of HBr. Br is 80, so then that is 81 grams in 1 mole. So 32.5 over 81, 0.401 moles. Okay, so I can use this number. Divide that by the molarity, 0.5 molar. So 0.401 over 0.5, 0.802 liters. Okay. Oh, let's get got a point. Okay. So that's the end of the lesson proper, but one of the skills that I like to make sure you know how to do, that your book doesn't teach very well, it doesn't really get into it, is dilutions. And so this is your practice page. Okay, you have this page. They are numbered. The first 3 are molarity. So it gives you the information, either the moles or the grams and the volume. Make sure you use liters for your volume, okay? And finding it just asks you to calculate the molarity, okay? The rest of these, I think all the way onto the back, are dilutions. So for a dilution, and it'll usually say, like you're diluting something, okay? The equation for dilutions is M1 V1 is equal to M2 V2. It's a very simple equation. So the molarity, the initial molarity times the initial volume will be equal to the second or the final molarity times the final volume. Okay. So that's how we would do these. I'm just going to work number 4 for you because we've seen problems like this. So you should be able to apply this, and then I'll leave the answer key as well. So my initial conditions, and for these, you need to have your volume in the same units. They don't necessarily have to both be in liters, but I'm going to put them both in liters this time. But as long as, if you have two volumes, as long as they're both in the same units, it works out. Okay. So I'm going to go ahead and change this to 0.050 liters. Okay, so here's my V1, right, and my M1. I'm going to dilute this so that I have not 0.05 liters, but I have 2 liters. Okay, so I'm going to figure out what's the molarity of my new solution. Okay, so I start with an initial molarity of 3.79 molar, and I have 0.05 liters. That is going to be equal to, I'm finding the new molarity times 2 liters. Okay, so I'm just going to divide 2 to the other side. So I'll do 3.79 times 0.05 divide by 2. So my new solution would have a molarity of 0.095 molar. Okay, and that's how you do a dilution problem. So some of these are a little more complicated. Number 5 is a little more wordy. But you're just solving. So because it's multiplying, they're all going to work the same way. Whether you're finding the initial or the final conditions, whether you're finding a molarity or a volume, they're all gonna be set up the same way. So you're gonna multiply one side and divide by the known quantity on the other side. Okay. So again, I'm gonna leave an answer key for these, so you can see how you're doing and check yourself. Okay.